Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 2nd, 2025, just yesterday. And this paper tackles how to let large language models safely improve themselves with very little human help. It shows that a guided self-play challenger solver setup called RFew can boost a model like QN38B base by plus 3.0 points on math tasks, matching General Reasoner despite that system using about 20 times more human data. The paper is titled, Guided Self-Evolving LLMs with Minimal Human Supervision. And as we will see later, the results for stable, low-supervision self-evolution are quite striking. Figure 1 shows that guided self-evolution keeps learning going instead of stalling. The left graph tracks accuracy over training steps, and it shows RFew steadily climbing while R0 flattens and then declines, which means the unguided method overfits to its own quirks. The right bar chart compares final scores across math and reasoning benchmarks, where the red RFew bars rise above all other baselines. Altogether, this figure demonstrates more stable and stronger self-improvement, with only light human guidance. Figure 2 explains how RFew actually runs this self-play loop. The top panel shows the challenger using a few human math examples to ask new questions, then rating each one by how uncertain the solver's answers look, which keeps difficulty in the medium sweet spot. The bottom panel shows the solver mixing those synthetic questions with human ones, learning from accuracy signals, so both players steadily co-evolve towards stronger reasoning. Table 1 shows that guided self-evolution gives consistently higher reasoning scores than unguided self-play, while using very little human data. The whole table compares several training strategies on many math and general reasoning benchmarks for two QN3 models. The upper block shows the smaller 4 billion parameter model, where adding RFew with just 1% human data, nearly reaches the much more heavily supervised General Reasoner. The lower block shows the 8 billion parameter model, where RFew, with 5% human data, essentially matches or slightly exceeds General Reasoner on the overall average. Figure 4 shows that guided self-evolution stays healthy instead of gaming the system. Reward hacking means the model learns tricks that boost training scores without becoming genuinely smarter, like padding questions with useless text. The left graph shows R0 losing question diversity, while RFew holds steady. The middle graph shows R0 inflating question length dramatically, but RFew keeps it flat. The right graph shows both methods raising difficulty, yet RFew does so without collapsing diversity or bloating length. Alright, wrapping up, 2 takeaways stand out. Guided challenger solver self-play keeps models improving instead of drifting, and it reaches near fully supervised performance with only a tiny slice of human data. That points to safer, cheaper self-improving AI systems at scale. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.